this second and final part of the interview, we will be focusing on topics like IT security, how to bring up the knowledge level within additive manufacturing, and what needs to happen in the coming 5 years to industrialize additive manufacturing on a broader scale. So I hope you enjoy this and stay tuned for future podcasts. So and the question was like, why is this not rolled out on a global scale in terms of this decentralized production idea?
Yeah, I think that there are various reasons for it. I mean, on the one hand side, I think it's again, I think the need and the motivation to do so actually really happened now on a stronger base during the COVID. I think everybody understood. And you know that, of course, perfectly, when we talked all about these face shields, that, of course, you can make an injection molding tool, but it takes a while.
Yes.
So, of course, if you have the ability to 3D print it, you put it in the printer and print it, and then you have it after 2 days. You have the first parts, and then you can just go on and print it. So it's also access. And then it also shows, and if you talk about your preferred parts, the nozzle swaps, for the corona tests, there now can see really we have several customers on the globe which are really decentralized, put now machines in to produce these nozzle swaps still today. So they're really growing a lot. And this is a bit a trend now that they say, okay, we understood we have to do that. And also it helps you also very much on the stock side and on stock levels. Because of course, if I can just print on demand, then even locally, that's of course also good for my inventory.
Yeah, but why is this not happening more? Because it seems like a no-brainer that, you can just, go to either a service provider or you set up your own machines in any country of the world, but we're not seeing this big rollout at the moment. I mean, is there something else that is limiting industrial companies or even consumers to really take full advantage of this?
I think there are a few things to consider. I mean, important is now, and this we learned a bit more intensive as well, is, when you really go from a prototyping or pre-series or, a validation process to a production process, it's tough. It's tough also for the suppliers to be able to fulfill the requirements. I mean, you have really a stable process that you are capable to keep the machines up and running, of course, 24/7, ideally. And that you have also the right operator, that you have the right understanding, know how to do this. And I think there is still maybe a few hesitations on the market from customers. Oh, shall I step in there? Shall I take this now? Is there the market? So what we have to do entirely is to work together, and this is an industry task, on applications where we all know and where we believe this is something we can really grow, and this is really beneficial for 3D printing on the one hand side. On the other hand side is also that the technology is on a phase, where not all applications would fly. And why? Because we need to still work on the cost per part. I mean, if you know, okay, even if it's a great technology and you can do decentralized production, all the buzzwords, but still at the end of the day, if I have to spend 10 euros instead of maybe my cost per part is 5 euros, I will not do it, even if it's whatever old technology. So we need somehow to make sure that we bring the cost to a level that, there's then really this hockey stick effect that you really grow this technology on a wider base. And if that is happening, then of course this decentralization will also accelerate very much. I mean, we see now it's going on, it's moving as on the metal side, but also on the polymer side. But I think this is still the hurdle what we have, that the entirely know-how and understanding about the technology is not yet there, that it takes fully off. And there is this reason what I just said.
Yeah. And I mean, data security or IT security, is that also something which needs to be addressed or tackled in a different sense? I mean, because I imagine if I have my product and then I want to produce it at a site somewhere where it's far away from me, so I cannot control the process itself. I mean, do I want to have, or do I have the possibility today to get the security to actually, I mean, okay, I want to print this, but I also want to make sure that you're only printing 5 of these parts. I don't want you to print 500 after you printed my 5 and then you sell it to a wider audience.
This is already what we have worked on at EOS, that we say, okay, we can now, let's say you would be a contract manufacturer, and then you produce a part for the company A in aerospace.
Yeah.
But at the same time, you produce another part for the company B in aerospace. And of course, now these 2 aerospace companies could be now really nervous to say, oh, if my data for the new design of an engine, for instance, goes to the other hand, then I have a big problem.
Yeah.
And there, for this, we have embedded in a software solution that we can make sure, okay, they can produce A and they can produce B securely. And they can also say, you can only produce 5 parts and then you can't do 6 parts. So we can already offer to the customer today.
So you can even regulate on amount and say like, okay, this is the fixed amount that you are allowed to produce.
Fixed amount or time, this is what we can adjust today. And then again, or maybe this is also something we have to address more to the market, that there is the security or this aspect happening. But on the other hand side, we need also to work now, because COVID shows us also we need to work much faster and more intensive on digitalization.
Yes.
On the service side, digital services, remote services, access to your machine. And then it could be that the client is nervous. Okay, well,
exactly.
Can EOS now read the data from aerospace A and aerospace B, which is also not the preferred solution.
Exactly.
So of course, this is something that we need also to make sure, and we need to educate the market. Okay, we have a solution, or if not the perfect, we need still to finalize it or improve the solution, that the entire market has a good feeling to use the technology on a global base.
Yeah. And I mean, if you look then at the market today, I mean, you said, when you started off, it was a lot of education and teaching, and I mean, do enough people know about the technology today and what is available? I mean, from our perspective, I mean, that's one of the key things that we do at Amexi is work with knowledge transfer and try to really get our customers up to speed with what they can do with the technology. But I mean, our perception is that there is still a lot more work to do. I don't know if you share that view or...
Of course, if I compare now what is today possible with 23 years ago when I started, is of course a total different meaning. But on the other hand side, we talk now also not only about prototyping, we talk about manufacturing. And that means also this requires a different understanding and a different information need. So I would say, yes, there's a lot of work we still have all to do to educate the market. Yes, you can use the technology. Maybe the people understood it's okay for a prototyping, but you can use this for manufacturing. It's stable, it's secured, it's okay. So this is now our entirely target. And of course, we have our Additive Minds consulting group, and you have, of course, your expert. Over the time, bro, there has to be also software solutions which can help additionally. We cannot just integrate a couple of hundred people and educate the global market. So we need also another step with software solutions that they, over the time, can do everything on their own. That we can step out a bit on the, let's say, beginner level of education, that we can really go back on the expert level of education. To how to manufacture digital factories and to integrate, accessories, how to come real to end-to-end solutions in certain applications. But I mean, and therefore I think we are still on the very beginning of 3D printing, which is industrialized and which is now taking off. And I think we are just scratching the surface. And I think there's a huge market if we do it all right. Customers, partners like Amexi, and suppliers all together to grow this. And I think what we have to achieve, and I think it's also very important that we really work on a standardization. And I think if you look back, I think when was it, 20 years ago, when the telecom person, I forgot now the name, but when he brought the GSM net, on a global, and European base together, because before it was, we work in Germany, but then Austria had its own net, but it was not cross territory. And then this one guy, he said, okay, we need to have a standard, and he established then really the European GSM standard, you know, and I think something like this we still have to achieve also in AM, because you know we have interfaces to post-processing or post-processing machines. You know, others take different ones. You know, I think we should really have one standard, because if you have one standard, it makes it easy for the customer, and we probably could really much bigger develop the market and the technology.
And I think that is an interesting topic as well. I mean, when we look at standardization, because that is a major topic. And I mean, I know for a fact there is a lot of experts that have spent many years in this industry that are pouring their know-how and everything into the standards work that is currently ongoing. But I mean, should it go faster? Or I mean, what is the key there to also really get the standards in place? Because I mean, everyone is contributing as much as they can, but I mean, is there some sort of lever here or something that needs to happen to sort of really push this further?
I mean, of course, there are the different organizations which work on the certain standards, but I think it helps, but I didn't see so far yet this big breakthrough. I mean, if you talk to certain customers in certain industries, they still tell me the same as 5 years or 10 years ago, that, well, hey, you need to really have a standard, because if you buy the machine A and well, I might buy the machine B from a different vendor, but then I would like to use the same interface. And if you have all different ones, it just will have one effect. And the effect I will not as fast as I could do, grow the technology in the company. And I think this is something we have to learn and we have to do better. I don't have now the solution here, but this is just the perception from the market.
Yeah, and a clearer maybe end user requirement, as you say. I mean, being very specific and very clear on the fact that, okay, but this needs to be there, otherwise this is not going to work.
Yeah, and I think also, you know, if you go back to, you know, we have on the one hand side, we have the machine, the hardware, software, which is important. But on the other hand side, we have also the process. And to have the understanding about the right process, so which is at the end, the machine, the material, and the process development. So how do I melt the powder? How do I melt in a way that have the best properties, the fastest process, the best surface? You know, this is also something which is very important, and where you can really, if you look on this, you can really do a lot more as today. And we work on very different materials and process parameters today is maybe just 5 years ago when we talk, for instance, to metal. So the topic material is also key on the metal and on the polymer side. Of course, if you have now a flexible material like a TPU material on the polymer side, you can explore different markets, different consumer group markets. And the same is, of course, if you have on the metal side a copper material or a specific alloy which you could also develop, or just the titanium. Of course, there are a lot of things what you can do, and then also to combine, you know, also to question mark: do you need, for instance, a full dense material? You know, do you need to have a density of 98 to 99%? Maybe you don't even need it, because if you understand better what is the requirement of the part, and you need maybe only in certain areas 60% density, of course you could accelerate extremely the build time, and then you also can bring down the cost per part. So all these things together, you know, we need to again train and educate the market what is possible, and to really think out of the borders also from a design perspective. That it's not now I can do everything what I want, really freestyle, and then I can even think, okay, maybe I can play a lot with the properties, because this is a benefit what the technology delivers in the polymer or in the metal side.
So Markus, then I mean, you started off as employee number 59, and today EOS is
around 1,300 people.
Around 1,300, and I mean, if you were to then list the top 3 challenges for the AM industry as a whole for the coming 10 years, what would the sort of key 3 things that needs to happen to make AM a sort of global industrial production process? What would those 3 things be?
I would say, beside the education, what we talked lengthily today, there are 3 things. Number 1 is, you know, you need to achieve a certain OEE with the machines. So this is mandatory. But on the other hand side, you need to balance it out, and this number 2, with an innovation, because, you know, if you get a productivity increase and a cost reduction increase, and then you can enter much more manufacturing applications. Because this is still a bit a hurdle today, that in a certain level we are blocked because the technology is not productive enough, or it's still a bit too expensive.
Yeah.
And so this is, of course, the OEE and innovation in a balance.
Yeah.
And the third part, I would say, is the industrialization in terms of how do you automate now such a solution, that really look what are the right applications which are perfect now for the AM and for the 3D printing industry, and how can I work there entirely to automate it, that I have really robots and that I have optimized the whole workflow.
Yeah.
And then if I do this one, I think I can, again, if I've solved the first two things, I can really grow the AM in a huge scale altogether, and we will have a lot of fun with new applications.
Yes.
A lot of customized parts. Maybe half of your body is then 3D printed.
Yeah, who knows? Well, there's exciting things in the future for sure. And Markus, once again, thank you so much for taking the time here today and talk to us about your experience in additive manufacturing and what's to come for the next years. And all the best. And thank you.
Thank you much, Edwin. It was really a big pleasure to
Yes.
talk to you, and I could continue with you another hour.
Yes.
But even each podcast at a certain point in time has an end, and
Exactly.
So now let's take it for the first round.
Yeah.
Okay, thanks a lot.
Thank you.
Bye-bye.
That was the final episode of our interview with Markus Glasser. I hope you enjoyed this and stay tuned for future podcasts where we will bring the human behind the technology to the spotlight in additive manufacturing.